Yo, so this cap had us exactly what we did in lecture this morning. We have some plank or some ladder, some object is on a wall, leaning at a 30-degree angle, and it has several forces acting on it, and the cap asks us to determine what the values, the magnitudes and directions of those five forces are. So we went ahead and defined a couple of things. We have, first of all, the mass of the plank. We said was 2 kilograms, and the length of the plank was 4 meters. We also said the mass of the object is 4 kilograms, and we have an object that's hanging off the plank 1 meter from the ground. So, with that defined, we went ahead and found where our five forces are. So we have a wall. This is a frictionless wall, so all we have is a normal force sticking out from the wall, going in the positive x direction. We have our two gravities going down, the gravity of the plank, which acts at the center of mass, and the gravity of the object that acts where the object is attached to the mass. We also have two forces that the rough floor puts onto the plank. We have our normal force that the ground exerts, and we have our frictional force acting in the negative x direction. So we can easily find out what our gravitational forces are because hopefully you know that 2 times 9.8 and 4 times 9.8 will give you your gravitational forces. So the first thing we need to do is we're going to go ahead and set our axis of rotation at the bottom of the plank. And because we set our axis of rotation at the bottom of the plank, that allows us to ignore these two unknown forces when we do our net torque statement. So it only leaves us with our two gravitational forces, which we already know, and our normal force of the wall does, which is what we're trying to find. So we write our net torque statement. Our net torque is 0 because we're under rotational and linear equilibrium. And that's equal to everything that's going to go counterclockwise minus everything that's going clockwise. So the things that are going counterclockwise are our two gravitational forces. We have the gravitational force of the object, which is now multiplied by its distance and its angle will give us our torque. We have the torque of the mass of the plank itself. You add those together and you subtract our torque at the wall from the normal force the wall is exerting, and that's we plug in our numbers, and we know again that the gravitational force of the object is going to be 4 kilograms times 9.8 meters per second times the distance from our pivot point, which we defined earlier to be 1 meter. And we're going to multiply it by our angle. And our angle is going to be sine 30. Why? Because our plank is put up by 30 degrees. So we're 30 degrees off from being perfectly straight. So that's why we're having that at 30 degrees. Same thing for the plank, except you're going to exchange the mass out for the mass of the plank. And our thing of the wall. Now our wall, it's acting at 4 meters because it's the entire length of the plank. And its angle is not 30, its angle is 60 because this angle is 60 because this is 30, this has to be 60. Because normal means perpendicular, and perpendicular is 90 degrees. We plug in all our numbers. We solve for our only unknown, which is our normal force in the wall. Solve for that, we get 11.3 newtons. Okay, we're 3/5 the way there. Now all we got to do is find out what the ground is exerting on the plank. We got to find the normal force, we got to find the frictional force. Well, now when we go into our linear motion, we're going to consider our force in the y direction first. We know that our net force in the y direction has to be 0 because it's not moving. So it's going to be equal to everything going up minus everything going down. Well, there's only one force that's going up. Our normal force of the ground, the thing we're trying to find. And there's two things going down, our two gravitational forces. We've already calculated those. You plug it into the statement here, you get 58.8 newtons. And lastly, to find our last force, our force of friction, it's going to be our net force in the x direction is 0, which is equal to everything that's in the positive direction minus everything in the negative direction. And we have only two forces acting in the x direction. We have our net force, or our normal force of the wall, minus our frictional force the ground exerts on the plank. Well, we already calculated what the normal force of the wall is. And since there's two forces, they have to be equal but opposite, which means the magnitude of our frictional force is also 11.3 newtons, except it's acting in the negative x direction, just like we did in class.